My name is Raja Srinivasan. I work for Riverbed. I'm the Director of Cloud Solutions at Riverbed. And last time I was here, I was representing a company called Zeus Technology. And I'm going to talk to you about what Zeus Technology is doing with RightScale. And as part of my presentation, the agenda today talks about maximizing your application on the cloud. And we have been working with RightScale for about 15 months now, and we went into revenue with RightScale in April. And those of you who were at the party last night, I told you, thank you to RightScale. I just sit back and collect the money. I forgot to add one more sentence, and that was, every month, the money that I collect goes up by 10 to 15% because of my relationship with RightScale. So it's thanks to the customers, and thanks to RightScale for adopting our technology. So when I said Riverbed and Zeus, kind of confusing, isn't it? So what do I mean by Riverbed and Zeus? We are Riverbed. Riverbed acquired a company called Zeus Technology in July. They acquired a company called Aptimize in July. So the product I'm going to talk to you about is based on these two acquisitions. Riverbed itself has a few other technologies that we are in the process of building into the RightScale template model, and it will be available through RightScale, hopefully in the near future, hopefully in Q1 2012. And you're going to see a progression of events taking place and some announcements. Right? So what is Riverbed and why did they acquire Zeus Technology? They acquired Zeus and Aptimize primarily because they wanted to play a big role in the data center, not just in the WAN optimization space. So who's Zeus? Okay, Zeus is, we've been in the traffic management, load balancing, application delivery controller. These are different terms you'll hear in the marketplace. We've been in the ADC business for about 8 years. We are the leading software-based ADC in the market today, bar none. And we have the fastest performing product in the space. We are known for our innovation. We are known for our success. For a very small company, we have some real high-profile customers and clients. And later on, I'm going to talk to you specifically about one customer who has deployed us today in the RightScale environment. Unfortunately, he's not available to be here with us, so I'm going to take on his persona and talk about why they chose Zeus. And we are a pretty small company. For the success that we have had, we have remained small, we have remained very focused, and we have been technically focused. So what is Aptimize? Aptimize is a company from the other end of the world. With Zeus is from Cambridge, England. Aptimize is from New Zealand. And they are known for their innovation. They are also known for their success. What does Aptimize do? I'll spend a little bit of time. I have one slide on Aptimize and we'll talk about it, but essentially they are a web browser optimization product. And the two together we have come up with a new branding and a new product, and we are calling it the Stingray product. We are known for our performance, and we want to be part of the globally connected enterprise. Okay, that's a corporate pitch. Now let's dive down into the technology and talk about why, when you deploy in the cloud, performance is very important, and availability is very important, and security is very important. Those are primarily the three broad criteria that we go by. This is not something I'm saying. This is something that our customer base is saying. This is something Riverbed's customer base is saying. This is one of the reasons why Riverbed acquired us. So they did a survey of the marketplace. They did a survey of their customers. We have more than 1,000 customers. Aptimize has several hundred customers, including Microsoft itself, in the web browser space. So they talked about what are the customers' problems, what are the challenges they face, and many of the challenges, based on the importance and based on the number of responses that we got, we literally got hundreds of responses. Consolidation, disaster recovery, mobility, rich media, cloud computing. More and more, cloud computing is becoming important. This survey is a couple of months old. If we do the survey now, I'm sure cloud computing will rank higher in this list. Performance management. Offshoring. Offshoring means not just development, but also operations staff. So your data center could be here in the US, and your staff could be in the Philippines or India or Russia or wherever, and because people want 7/24 operations, they want to start accessing your data center, performance, web performance is critical, it's important. And we can accelerate any of these key initiatives, right? So how do we do this? We have three broad product categories. I'm not going to spend a lot of time on the Steelhead. I talked about it. Let's move on. I'm going to talk about Stingray Traffic Manager. That's where I'm going to spend an enormous amount of time, and we are going to show you how you can measure, track performance, and optimize your applications in hands-on demo after my five minutes of fame is over. And we're going to, and I'm going to talk a little bit about the Stingray Optimizer. Okay. So what is a Stingray Traffic Manager? If you are a RightScale customer and a Zeus customer, you will recognize this as the Zeus Traffic Manager. It's exactly the same product. Stingray is the Riverbed branded version of the Traffic Manager. We are a software proxy. We are a load balancer. Right? We operate on top of an operating system. We are not a layer 3, layer 4 load balancer. So we terminate TCP traffic that allows us to do certain things, that allows us to provide you with a certain level of security that you would not get if you were using something like HA proxy, for instance. It's software. It's available on Linux. We run on RightScale as a template on Linux and on Zen. We run on Amazon AMI. We run on several different cloud platforms. We run on Solaris, including Solaris x86. We run on VMware. And we have a VMware-based appliance that you can download and run without an operating system. And RightScale, as I said, we are generating revenues to RightScale, and we have several very large Fortune 50 clients running on RightScale. Okay, so what exactly is an ADC? ADC is a term that was coined by the Gartner Group. They have to make their money, so they imagine new ways of creating new terminologies in new markets. ADC is nothing but a very advanced traffic manager or a load balancer. ADC has multiple features. They have multiple functions. You would need an ADC or a load balancer if you are running any one of these applications in the middle, a website, an enterprise class applications like SAP or Oracle. You're running email, SMTP or IMAP or POP, web services. We can load balance databases. You have rich media. You have audio, video stuff in your database that you're providing, your services that you're providing. You would need an ADC. So what are the typical functions an ADC would do? Some of the typical functions would be you can do SSL offloading, XML offloading, content compression and content caching, which is very, very important if you have rich media. You want to do it reliably. You have half a dozen different load balancing algorithms that you can choose. You also have some bandwidth management controls. So you could have a freemium service. You could have free services as well as paid services. And you want to make sure you want to optimize your throughput for your paid services. An ADC would provide you some of those features. You also want to make it pretty secure, and you want to isolate your traffic. What's a use case for this? The Barack Obama political campaign is a classic use case for security. The Republicans tried to take their servers down, and they started using us, and they were able to optimize their services, identify where the attacks were coming from, and block those attacks. We are not a security company, but we provide some security features. And this is our key factor, is you want something that is very simple and easy to deploy, and that's also very simple and easy to use. So we have a traffic language built in. The traffic language is built around shell scripting, PHP, Python. If you know those things, you know our traffic script language. And we have a very rich GUI interface that allows you to manage and deploy your applications using the Zeus, I'm sorry, I should say Stingray now, the Stingray Traffic Manager. Optimize, again, I'm going to show you the slide. This product set is available as a separate standalone product from Riverbed. In a future release, We are going to work with RightScale and integrate it into the Stingray product offering, and you should see this coming out in the near future. And as I said before, it's essentially a web content optimizer. It has something to do with browsers, and that's about all I know about this product at this time. Okay. So why would you use Zeus and not something else? It's designed from the ground up to be a software product. We did not come from a hardware space where we took the product and we kind of formatted it for software. We designed it from the ground up for software. Okay. People come to me and say, you know, I'm going to deploy in the cloud. I have a problem with performance. You guys cannot perform as well as a hardware-based appliance. We have recently published some outstanding performance studies where we support 40 gigabit throughput in a standard x86 box using 4 10 gig NICs. Our competition, the hardware-based competition that is telling everybody that Zeus cannot perform, is still playing around with 1 gig and 2 gig NICs. They just put 2 1 gig NICs. Right? I'm rapidly going through this because I want to get to the demo. That's what's that's where you're going to see a lot more interesting things happening. Okay. So using Stingray Traffic Manager, what are the different things that you can do? You can develop your applications, deploy your applications, deliver your applications, and defend your applications. And I'm rapidly going through 4 slides and show you how you can do some of these things. Developing your applications is really simple. You have an application, you have it deployed, you have a load balancer in front. As you make changes to the application, all you have to do is bring up another app server, attach it to the load balancer, switch your load to go to the new app server, and take your old app server out. If it works, great. If it doesn't work, you can roll back. So your application development methodology and the way you deploy it becomes really, really fast. So, and deploying, since we are software based, there is no truck involved where you have to bring something in and do a screwdriver upload. You can basically deploy the application as and when you want. And when you talk about the cloud, you want to be able to deploy your applications on the fly, and we enable you to do that. And part of delivering applications means we have some advanced features that we call autoscaling, and autoscaling allows you to scale your underlying web services to whatever number you need and scale it back when traffic goes down. And I'll give you a use case for this. Okay. And defending your applications, what we have is, we are not a security company, but we have certain things in the product that allows you to protect your application from attacks, from SQL injection attacks, or from or if you have data leaking from your application. Because we terminate TCP traffic, we have access to the entire message that is leaving your system. You can manipulate that traffic, and you can basically block out some critical information that's going out. Here's a funny story. Social security numbers were leaking, so one of my customers basically decided he wanted to stop it. Then they had a better idea, so instead of stopping the traffic from leaking, he generated random numbers and replaced real social security numbers with random numbers. And then he logged it, because he logged the IP address where these numbers were going to, so that they were able to actually track who was breaking into that system. So instead of basically blocking that request and stop sending message out, he was sending garbage data out, and by using the log files, he was able to trace who was trying to break into that system. Okay. And the last couple of slides I have before I hand over to Jim is, we have a couple of customers who have deployed on the RightScale Amazon environment. One of the customers is 10th Wave. 10th Wave is a marketing company located out of New York. They are a digital advertising and promotion agency. There are about 100 people. They've been in business for a couple of years now. And they have online campaigns that change on a frequent basis. And they have several active campaigns today that are running in the Amazon cloud. So their requirements were really very simple. They want to be able to deploy on demand. They wanted to promote themselves as being green. That means they don't want to use too many virtual machines, and they want to scale on demand. When traffic starts hitting and they fell below a certain threshold for their SLAs, they wanted to scale and deploy more web servers so they can provide services in a reasonable amount of time. So this is a real case study. They were able to save 75% of their web servers by using Zeus. And they demonstrated higher throughput and performance because they were using an open source product before us. When they went to Zeus, there are some comments that I have in the next couple of slides to show you how they got to where they wanted to be. They started using a couple of unique features that we had. And their benefits are essentially reduced time and energy cost, because they promote themselves as being the green advertising agency, and seamless experience for their customers. So reduced activity under heavy load. They had a stop bullying, speak up now application aimed at, this is a Facebook application aimed at teenagers. Under heavy load, they expected that their application web server requirements would be between 10 to 40 web servers. Using Zeus, 3/4 of that requirement was reduced, and they now using between 3 to 10 web servers that they are able to scale up and down as and when demand occurs. The reducing time and energy with SSL offloading. If without Zeus, they would have had to purchase 40 different SSL certificates for each one of the 40 web servers that they had. And managing those SSL certificates required, according to them, half a full-time equivalent.
So there are other, I guess downstairs at the expo, there are other companies that have scheduling and workload placement products. Mm-hmm. And it seems like you're doing some of that by scaling up and down the infrastructure. Mm-hmm. But then those products also do lots of other things. So I'm just trying to understand how your product that does some scheduling in terms of looking at the workload and maybe turning off a bunch of servers or VMs, how that interfaces with other people who have, I guess I call them cloud infrastructure managers that do scheduling as well as many other things.
Yeah. So there will be a little bit of overlap, but not a whole lot. What we have is something called autoscaling feature, and that's what TenSwave is using. So autoscaling basically means I'll give you some off-the-wall examples. So my timing to make it real is going to be really, really bad. So let's say you have a web application that you're providing services for, and the web application, you have SLAs built for that web application. So if you say, if I give you 5 seconds to 7 second response time, I'm going to charge you X number of dollars. If I give you 7 seconds to 9 second response time, I'm going to charge you less dollars. So for the higher dollar charge, you need to have, you've done this internal calculation, you know your application, so you're going to deploy, let's say 3 web servers, right? So what we do is we monitor the response times back from the web servers that we are managing. And when the response time exceeds a certain threshold or falls below a certain threshold, we can send triggers out. So let's say in this case we exceed 6.8 second response time, we send a trigger out which says, hey, you're going to reach the upper end of your threshold, please provision an additional web server. So we don't do the provisioning, somebody else does the provisioning, but once it's provisioned, you let us know, the management interface or the scheduler will let Zeus know that an additional web server.
Monitoring.
We do the SLA monitoring.
But then you're maybe messaging this another tool.
Yes.
Schedule. Okay, so you're not really doing the schedule.
We are not a scheduling company. We don't do this. And we do the other thing too. The other way too. So if response time drops to 5.2 seconds, then what we do is we automatically shut off traffic to one of the web servers and gracefully turn it off. And then we tell the monitoring tool, you can turn the switch off on that. We don't need it anymore. And if you're deploying in the cloud in a virtual machine, you're paying by the virtual machine, this becomes a cost-saving factor, not just a green factor. And that's exactly what TenSwave is doing, right? Now I'd like to have Jim Young come in and talk more about how to monitor for performance and how to start using our product efficiently.
I'll just give you a very quick 2-minute introduction to the product. This is the RightScale or RightScale dashboard from which you can launch instances of the Stingray product via their deployments mechanism. What I'm going to show you here is an instance of the product that I've actually got running on my laptop. So to manipulate and configure the product, we use a browser-based interface. We'll run in any browser. What I'm running here to demonstrate the product is 3 virtual machines. 2 of them think of as back-end web servers. They're actually running an early Zeus product called the Zeus web server. We no longer sell that, but it's still considered a very performant web server. This 3rd virtual machine is actually the traffic manager virtual machine itself. That's where we've deployed the traffic manager software. So I access the machine via HTTPS, point to the machine name on port 9090. I'm going to log in as the admin user. Now, very simply, to understand the architecture, the software architecture here, you have to understand 2 key concepts. And that first one is a virtual server, and the second one is a pool. So within the traffic manager, as we listen on whatever port and IP address that you specify, we terminate all requests or traffic coming into the traffic manager. We can then manipulate the traffic in a variety of ways, some of which I'll show you today. We then reinstantiate that traffic to the back end. So where we terminate the traffic, we use a construct known as a virtual server. And within the administration console here, that's where we define and create our virtual server. In terms of directing traffic to the back end, we use the concept of a pool. In the simplest form, a pool is really just a collection or a listing of back-end nodes, IP addresses of back-end nodes. So the virtual server here that I'm going to use for demonstration purposes is called website. And it has a bunch of parameters associated with it, which we'll look at some of those. And then the pool associated with that is also called website. So if I jump into there, I can see my 2 back-end nodes I've called back-end 1 on port 80 and back-end 2 on port 80. So really that's all I need. What I can now do is on this browser here, I'm going to point directly at the traffic manager, and we see a anyway, you can see up in the top left-hand corner, depending on how the request goes through to the back end, it'll signify back-end 1 or back-end 2. So that browser is pointing directly at the traffic manager. The traffic manager, in turn, is pointing to my 2 back-end nodes. There is no limit on the number of back-end nodes. You could have hundreds, and quite often that's a common deployment scenario. When you get to that level of configuration, configuring it through the web-based user interface is still doable, of course, but we have a SOAP-based API which you can programmatically configure new virtual servers, manipulate pools, etc., rather than having to go through the back-end web server. What I want to focus on today is some of the features within the product that allow you to visualize the traffic and monitor performance and manipulate performance of the traffic going through the traffic manager. To that end, I'm going to use a tool called Zeus Bench. So the parts of the name still survive in the product, I guess. Zeus Bench is a similar, if any of you have used Apache Bench, it's very similar to that. It actually comes out of the same core code. So I've got a Zeus Bench command here, which I'm going to use to fire off requests to my traffic manager. A little bit of a contrived example because I'm actually running this on the traffic manager itself, which you normally wouldn't do because for performance reasons, you do it from another system, but for purposes here, this will demonstrate. So I can now fire off requests. What this is doing is just sending 30 concurrent requests with some keep alive parameters, and it's just going to run until I stop it. And the 1M signifies that it's requesting a 1 megabyte file. So if I go back into our traffic manager, we have a tab called Activity. And the default chart that comes up is the bandwidth chart. So what this shows you is a visualization of the traffic going through going through this particular system at this point in time, based on the traffic that I'm generating from the Zeus Bench command. This will run continually until you stop the traffic. As you can see, I can terminate the command here, go back here, and in real time we should drop down to 0. So let me start that back up again. Now, this particular feature here is quite powerful in terms of the metrics that you can visualize to get an idea of the traffic going through your system. So out of the box, we're just looking at bandwidth bits received by the traffic manager from clients, and as you can see, it's around about the 400 meg mark at this point in time. I can actually click here on Change Data, and I can check any one of these points here, and they become a line on the graph. So there's essentially a large number of combinations you can use to plot the traffic going through your system. Now, I can modify the traffic in real time going through the system using some of the features of the traffic manager. For example, if I go back to I mentioned the notion of the virtual server, and there's a bunch of parameters associated with that. The key points about the virtual server are simply that three things. You have to give it a name, an internal protocol which you're using, and a port that it's listening on. You can optionally specify specific IP addresses. One thing I can do is apply what I call a bandwidth class at this point in time. So I've created a bandwidth class called BWT3, which equates to 45 megabits per second. So I've selected that. I'm going to update that against the virtual server. If I jump back to my activity, we should see our activity drop dramatically to about 45 megabits per second. So that's one way in which you can manipulate performance. So you can apply these restrictions, if you will, to various classes of user within the system. You might have a scenario where you have premium users, where you want to have the best response time possible and the best bandwidth possible. And you might have guest users who you want to have restricted bandwidth. And this is one way to do it, by applying a bandwidth class here. The key point here is that all of this can be done in real time. So if I go back to my virtual server, what I'm going to do now is simply turn that off, that bandwidth class off. Jump back to my activity, and we should see it jump back up. Okay.
So in theory, the latency should have gotten a lot worse when you start throttling the bandwidth on those requests. Correct?
Potentially.
Can you show that as well? Can you show the latency on that?
Actually, I would have to look in. I don't know if there's any metrics specifically on the when you say latency between from the client's perspective. Yeah. No, the metrics here are more geared towards the traffic going through the traffic manager. They're not really looking at it from a client perspective. You would need another tool to look at latency. It's more looking at it from the perspective of the traffic going through the traffic manager. So that's one aspect of the visualization. Another aspect is another way to apply what we actually call in the product rate classes is using an extended feature of the product called traffic script, and this is one of the real differentiators of our product. So for every request that comes through the system and a response that comes back, we can apply a rule to that traffic. That rule is written in a language, an embedded language called traffic script, syntax similar to PHP. It's very powerful. It's a kind of a full-blown language, and you can do some pretty impressive stuff with traffic script in terms of manipulating the traffic. One very simple example is I've created a what I call here a rate shaping class, and I've limited the rate here to a maximum of 60 requests per second. Now, the way I apply that rate is, again, go back to the virtual server. This is where all of our parameters essentially hang off this virtual server. We do have some, obviously, with the pool as well, but we'll get into those in a minute. So I can now go into my rules, and I'm going to say apply this rule, which the rule is called apply rate. If I actually look at the traffic script, it's a simple line that says use that rate class. So now I'm going to change my request to this one, where it's just actually requesting the default index page. And I'm going to go into activity, and I'm actually here going to change the chart type. So we come with a standard or inbuilt number of charts, one of which is TCP requests per virtual server. And we should see the request per virtual server sitting around about 60. Yeah, my virtual machine is acting up a bit here, so we're getting a bit of variance, but what I just quickly wanted to demonstrate is when I go back into the virtual server and take off that rate class, remove the rule in effect, and go back to my activity tab, we should see it. Yeah, it now goes right up to approximately 1,300 requests per second. Okay, so there are two ways of applying performance criteria within the traffic manager, enforcing particular performance profiles. Obviously, this visualization of the traffic is a good way to gauge performance overall of the traffic itself as well. If we move on now to the historical activity tab, this also monitors. This essentially monitors the same thing. There's a less number of things that it keeps in its database, and it can track traffic over a period of 90 days, so you get a much longer, a wider view of the traffic. Again, on the visualization for the activity, this is particularly important when you've got a globally deployed application. This application can be used to visualize requests coming from any user around the world. So a dot will show up on the world map depending on the number of requests emanating from that particular location. Now, let's move on to the Connections tab. I've still got my load generator running here. This one is quite important from a performance analysis standpoint. This will show you, I've got some parameters set up which dictate the number of the amount of traffic that it's going to keep in memory here, but it's quite useful, as I say, for analyzing traffic. So I can click on. Fortunately, I'm scrolling across here, so I can't quite see, but I can click on any one of these and dig deep down, or dig directly down, I should say, into that particular request. So we get a summary of the connection itself. We show which virtual server it's using, the IP addresses, any rules that are in place. We can show the details of the request and the response. We can also show a trace. And this is quite important from a performance troubleshooting standpoint. So you can see on in this case, a millisecond basis, each call that's made to facilitate that particular request or response. And you can quickly see, simply by looking at the time, if there is a bottleneck. So we may have, for example, written a traffic script rule, which turns out to take, half a second to run, and is thus causing a bottleneck in the traffic. This will show that up very quickly because it'll analyze down to the particular rule as it in its stack there that it shows.
Is that in a debug mode, or that's running all the time?
Good question. It's essentially in a debug mode. It's you wouldn't normally have it on because it does impose an overhead of probably about, particularly the request tracing imposes a little bit of an overhead, probably of about 15%. So in a high volume production mode, you would not have that switched on. Okay. A couple of last things on the connections tab here. We can apply filters very easily. Say, for example, we wanted to simply, well, first of all, on the to column here, which is the back-end node, we can see that it is load balancing across 129 and 130. And we'll get into the load balancing algorithms in a sec. But for example, if I simply wanted to look at all of the traffic going to 129, I can click there to apply a filter, add the filter, and that reduces my list to the traffic going to that particular node. So again, quite a powerful tool for analyzing and zeroing in on particular types of traffic that may be of interest. The draining node tabs allows you to, you can actually specify one of the nodes at the back end as draining. So if you want to take it off gracefully for, say, maintenance reasons, you can do so. And that simply means that no new requests will go to that node. We can turn on caching as well for performance reasons. This will give you a visualization of actually what's in the cache. There's logging that can be switched on in terms of the request logging. If necessary for troubleshooting purposes, you can turn that on, or for performance reasons. Finally, just to finish up here, I wanted to talk about the back end and the load balancing. As you see here, I've got a pool. I've named it website as well, the same name as my virtual server. And as you can see here, I've got two nodes, both set to active. This is where I would set them to either draining or actually disabled to take them out of commission. So against the pool itself, we specify, logically, this is where we specify how load balancing is going to do. So what load balancing algorithm is going to be applied. So by default, we're going to do round robin, but you have 7 algorithms there, depending on the type of traffic. You may get better performance, for example, doing least connections or a fastest response time. So it monitors response time from the back end to apply those that load balancing criteria. Any questions other than what's already been asked? Yeah.
Can you do SSL pass through with this, or does it have to terminate the SSL?
It does not have to terminate the SSL. You can do SSL pass through. By default, well, I wouldn't say by default. Ordinarily, we do SSL decryption simply because if you're doing any manipulation of the traffic, you have to decrypt it to be able to have visualization of that traffic. But that doesn't apply to the visualization that I just showed you. It applies to, say for example, you wanted to examine a header, a host header. You would need to decrypt that traffic in order to do so. But yeah, you do not have to do that. You can do SSL pass through.
Another quick question. In the RightScale use case specifically, do you support the auto registration capabilities of the, for the app servers? Like, can they, via some API or something, say, hey, here I am, add me to the cluster?
Yes, absolutely. Part of, and this kind of gets into the area of autoscaling as well, because they have to essentially register with the traffic manager. The traffic manager has to know about a new backend node or the subtraction of a backend node. So yeah, we do support that.
So we had a lot of discussion about the traffic manager itself. There's one other module to the traffic manager that we have not talked about, and we should probably talk about it in a future state, is we have an application firewall module that is part and parcel of our traffic manager, and that's also available through the RightScale templates. The application firewall module gives you helps you meet PCI DSS compliance. It's actually a superset of rules that you can apply to the traffic. So you meet PCI DSS compliance, HIPAA compliance, Sarbanes-Oxley, some of the Asian compliance. So it's actually a superset of the rules that we have found throughout the world. And we have it as an option to the traffic manager, and you can also deploy it as its own standalone product.
Thanks, everybody. Thanks.